Okay, objective number 2 really isn't difficult if you remember what the law of conservation of mass means. Conservation of mass is talking about you can't create or destroy atoms. What you start with has to equal the mass of what you end with. And sample problems on each of these objectives, I've got places you could find extra problems to practice. Keys for those are loaded from your problem sets. But if you're asked to show that the law of conservation of mass holds true for this balanced equation, the first thing you need is the balanced equation. And as we've been warning you for the whole trimester, you have to be able to do this. You have to be able to do it correctly and fairly quickly. So magnesium metal, I know will just be Mg. Hydrogen chloride, hydrogen loses 1 electron, chlorine gains 1 electron. So a +1 and a -1 means I just need 1 of each. And it's going to produce magnesium chloride. Magnesium gives up 2 electrons, chlorine only takes 1, so it's MgCl2. And hydrogen gas, I know, is H2. So balancing would just take a 2 here.
Daniel Young to the attendance office for your ride, please. Daniel Young to the attendance office for your ride.
So now that I've got the balanced equation, how can I show that mass is conserved in this reaction? I need to get my periodic table out and look up the mass of each piece. So magnesium, I look up, it's 24.31 grams. And I'm going to take 2 times the mass of HCl, so 1.01 plus 35.45 times 2. And that needs to be equal to 24.31 plus 2 times 35.45 plus 2 times 101 on the other side. So that if I go ahead and just get my calculator out, you should be able to see that you've got the same thing on each side. But if you add them up, they should actually equal each other. 24.31 plus 2 times the 1.01 and the 35.45. So I'm getting a mass of 97.23. And when I add up the other side, I should get that same mass. And that's all objective 2 is asking you to do. Get the balanced equation and show that you get the same mass when you add up all the pieces for each side.